orbit to the first. So when we've got 4 levels, the possibilities we have are 1, 2, 3. You can have if the electron's here, it could jump from there to there. That's 4, 5, and 6. Okay, so there are 6 possible transitions when you have 4 levels. So when you have 4 levels, you have 6 possible electron transitions. Let's say we have 6 levels in the question, and how would you work out how many possible jumps the electrons can make? So the transition, the de-excitations, one easy way is knock off 1, that's 5 plus 4 plus 3 plus 2 plus 1. And for 6 levels, there are 15 possible transitions. Okay, so if you use that technique for the first example, 4 levels, that will be knock off 1 from 4, that's 3 plus 2 plus 1. And that gives you 6 possible transitions. And sometimes these questions also come up in your exam. So let's just confirm what we've just said, and the slides will do that. Okay, so electron transition, what is it? When an electron moves between energy levels, that's what we call an electron transition. Now, when an electron moves down, we call that de-excitation. When an electron moves up, we call that excitation. So how can an electron move up an energy level? Okay, there are a couple of ways. We've talked about de-excitation. So when electrons move down, okay, why would an electron move from a high orbit to a low orbit? If there is a vacancy in the lower orbit, then the electron will move down and they will occupy that possible vacancy. If there's no vacancy in that orbit, then the electron will maintain its orbit. Now, with hydrogen, it's simple because it's one electron. I mean, we know if it's in this level, there's always a vacancy below. So it's easy in our explanations. So when we have an electron sat in a higher energy level, it will spontaneously move down to a lower energy level and give off a photon in the process with an energy equivalent to the energy difference between these 2 levels. But how does the electron get up to that level in the first place? And this is what I want to discuss separately. So there are 2 techniques that we are going to look at and how an electron moves up an energy level. So we've got an electron sat here in a low orbit, let's say n equals 1, and we've got to move it to the n equals 2. We'll stick with hydrogen's energies, 13.6 electron volts and minus 3.4 electron volts. I've only chosen 2 energy levels here. So we've got this electron sitting in the lower orbit. Now, this electron can absorb a photon and move up an energy level But to move up from the n equals 1 to the n equals 2, how much energy is needed? The difference between the energy levels. So if the electron is going to move from the n equals 1 to the n equals 2, we call this process excitation. When the electron moves from a low energy orbit to a high energy orbit. And the opposite, when it moves down, is called de-excitation. So how much energy? That will be minus 3.4 minus 13.6 electron volts. And the difference is 10.2 electron volts. So the electron needs 10.2 electron volts to move from a low energy orbit to a high energy orbit. Okay. Now, if this incoming photon has 10.2 electron volts of energy, this electron will absorb that photon and move up an energy level. So this electron will absorb this photon and move up an energy level. Now, let's imagine that this incoming photon has 10.1 electron volts of energy. Now that is less than the 10.2 electron volts, and what will happen here is the photon will hit the electron and bounce off with 10.1 electron volts of energy. Now, that is an elastic collision. The electron will only accept exactly the amount of energy needed for it to move to the next level. If the incoming photon does not have the exact energy required to move up to the next level, it will not take it. Okay, these are the rules of quantum physics. The electron does not accept that energy. It has to be exactly 10.2 electron volts. So on that note, what if the incoming photon had 10.3 electron volts of energy rather than 10.1? So many of you will probably think that that's more than enough. So the electron will bounce off. So the incoming photon will give 10.2 to the electron, and the electron will jump off, and the remaining energy that the photon has is 0.1, and off it'll go. Unfortunately, that does not happen either, and the electron stays exactly where it is. So when it comes to photon interactions with electrons in atoms, exact amount of energy is required, which is the difference between the energy levels and nothing else. Nothing more, nothing less. So electrons could jump from the n equals 1 all the way to the n equals 4 in one jump, providing that it has the exact energy needed to make that jump. Anything less, slightly less, let's say something like that, it won't go. Okay, all the other levels in between are unstable. Unstable, rotational and translational energy level, they do not exist. Okay? So when it comes to photons incoming, they must accept the exact amount of energy. So the electron absorbs a photon and the electron excites to a higher energy level. Okay? Now, so the other way in which electrons can jump an energy level or several energy levels is if the incoming particle, now we're looking at particles, it's not an incoming photon. So what we're now looking at is an incoming particle, and let's say an electron. And this was discussed at the beginning. So we said the electrons were incoming, they hit the hydrogen. As a result, we had light produced. So how did that happen? So we've got electrons coming in, they are colliding with the atomic electron, transferring energy, and as a result, the electron excites to a higher energy level. Now, if the electron comes in with 10.1 electron volts of energy, it's insufficient for this atomic electron to excite. So if the incoming electron has 10.3 electron volts, remember with a photon, it has to be exact, but with particle-particle interactions, this electron could lose 10.2 electron volts of energy. The electron then excites up. The incoming electron bounces off, an inelastic collision, and it loses kinetic energy. And if it was to transfer 10.2 electron volts, it will have a remaining 0.1 electron volts, and off it'll go off in a different direction. Now this incoming electron is not an atomic electron, so it's not bound by the atom. So this, and it is an electron collision that has caused excitation. The previous example was a photon being absorbed and causing excitation. Now, once these electrons are in higher energy levels, what happens is there is something called spontaneous emission, and they de-excite. How long they spend at each level is determined by each atom. It's a decay constant, and from there there's a probability of where the electron can be, and that probability of it then moving down. We are not going to discuss that at A level. So just to go over the opposite, when the electron is sitting at a higher energy level, it can move down and in the process emit a photon with an energy E equals hf. Okay. Now, where is this observed? Well, when an electron de-excites from a high energy level to a low energy level, it gives off photon. This gives rise to line spectra. When